So for section 9.4, we're still going to be solving linear systems by elimination, but now we're going to add another step in there. These ones are ones that we can't just add or subtract going down. We have to change some numbers. So there's 3 steps here. Step number 1 is to decide which variable you want to eliminate, whether it's the x or the y first. Then number 2 is to multiply one or both equations by a constant so that adding or subtracting will eliminate that variable. So in other words, we're going to multiply one or maybe both equations by a number so that either our x's or our y's are eliminated so that we can continue solving. And then number 3 is to solve the system using the elimination method, just like we have been doing. So example 1 here, solve by multiplying. So we're going to look at this system. And right now, if I added down, I would get 5x and 6y. And that's not good. I want one of them to cancel out. So I need to decide which variable I want to cancel out. And it doesn't matter which one you do. One may be more work than the other. That's the only difference. So if I wanted to get rid of the x's, I'd have to make them both 6's because 3 and 2 both go into 6. And then I would have to make one positive and leave one, or leave one positive and make one negative. Now, if I went to the y's, I could just change that bottom, that -2. If I change that to an 8 by multiplying by 4, then I would have a positive 8 on top and a -8 on the bottom. So that would be less work for me. So that's the one I'm going to pick. And I'm just going to times everything in that that equation by 4. So I'm going to copy over the top one. I'm not going to do anything with it. And then I'm going to go through and multiply everything by 4 in the bottom equation. And everything means even after the equal sign. Now if I add going straight down, I'm going to have 11x. The y's would cancel. And I have 7 and a -40, which would make a -33. And then I'm going to divide by 11. And -33 divided by 11 would be -3. So now, just like before, I'm going to take that -3 and I'm going to plug it back into one of my originals. So if I plug it in the top, I'm going to have 3 times -3, which would be -9. And then I have plus 8y equals 7. I'm going to have to add 9 to both sides. And 7 plus 9 is 16. And then I have to divide both sides by 8. So y is 2. So my ordered pair is -3, 2. And just like before, make sure you put the x value first and then your y. Oops. Now for our next one here, again, looking at the x's, one's positive, one's negative, so that's good. I would have to make them 6 because 2 and 3 both go into 6. That's the smallest number they both go into. Or if I look at the y's, the top is 4, but the bottom is a positive 1. So I could make that a -4. Now, you could choose the x's, but you would have to multiply both equations by something. If I choose the y's, I only have to do that bottom equation, and I would have to multiply it by a -4 in order to make that y a -4. So just like last time, we're going to keep the top equation the same, and then multiply everything on the bottom by -4. And then I can add going straight down. So I got -11x, the y's would cancel, and 12 plus 32 would be 44. And then divide by -11. So x would be -4. And then I can plug that back into one of my originals. I'm going to pick the bottom one. 2 times -4 would be -8 plus y equals -8. Add 8 to both sides, so y would be 0. So my ordered pair would be -4, 0. Then we have this one, and my x's are 3 and 4, so they both go into 12. But then I have 9 and 13. 9 doesn't go into 13. 13 times 2 would be 26. 9 doesn't go into that. 13 times 3 would be 39. It doesn't go into that. So that's telling me I'm going to have some pretty big numbers to change by. So I don't want to do that. I don't want to work with those. I want to stay with the x's. I'm going to make them 12s. So I would have to times this one by 4 and this one by 3. And 1 is negative already, so that is good. I don't need to worry about that. So I'm going to have negative 12x plus 36y equals negative 12. And remember, I'm just distributing that 4 out there and timesing by everything inside. And then I'm going to do the same thing with the 3 at the bottom. So I'm going to have 12x, negative 39y, and 15. So then when I add down, the x's are going to go away. And I have 36 minus 39, so that would be a negative 3y. And I have 15 and negative 12, which would be 3. So divide by negative 3, y would be negative 1. So then I can go ahead and plug that back into one of the equations. If I do the top one, I'm going to have negative 3x. 9 times negative 1 would be negative 9 equals negative 3. I'm going to add 9 to both sides. So I'm going to have negative 3x equals 6. And divide by negative 3, x equals negative 2. So then write your ordered pair, and you are done. Oops. One more here, no negatives. Looking at the x's, I have 2 and 5, so that would have to be, I would make them 10. That's the smallest number they go into. Or the 3 and 2 make 6. So they're all positives, so that doesn't help me out. So you just get to pick. Do you want it to be the x's or do you want it to be the y's? I'm going to go with the x's this time just because we've done the y's a couple more times before. So in order to be 10 here, that's going to be a 5. In order to be 10 here, that's going to be a 2. Now again, we have to make one negative. I'm going to choose this one just because I'm looking right here, and that's going to turn positive. So that would help us out there with that negative 12 being a positive 12. Again, you can pick whichever variable you wanted to change. You're going to end with the same result. Your work won't look the same, but your end result will be the same. So now I'm distributing that 5. So I have 10x plus 15y equals negative 5. And I have negative 10x minus 4y equals positive 24. And when I add going down, the x's are going to be gone. 15 and a negative 4 would make 11y, and 24 and negative 5. And this would leave you with 19, and then you have to divide by 11. This one is not going to work out nicely. Y is 19 elevenths. So then if I plug that back in, I'm going to have 5x plus 2 times 19 over 11 equals negative 12. So that's 5x plus 38 elevenths equals negative 12. And then I'm going to subtract 38 elevenths from both sides. 5x equals negative 15 and 5 elevenths. And then we have to divide that by 5. And that gives me, oops, x equals negative 3 and 1 11th. So negative 3 and 1 11th. And then 19 over 11 would be 1 and 8 11th. So that one definitely did not come out nicely. And of course, we can use a calculator for these. All right, for the last one, it says Jessica spent $14.85 to buy 13 flowers. The bouquet contained daisies, which cost $1.25 each, and tulips, which cost 90 cents each. How many of each type of flower did Jessica buy? So we know that there's daisies and tulips. And the two together are going to equal 13 flowers. We also know that the daisies are $1.25 each, and the tulips are 90 cents each. And they're going to cost $14.85. So now I get to multiply the top by something, whether it be the $1.25 or the 90 cents to cancel out one of those. I'm going to just do negative 1.25 right now because the bottom is positive, so we want that top to be negative. So it's going to be negative 1.25 of the daisies plus negative 1.25 of the tulips is going to be 13. And then we're not going to do anything with the bottom row. And then we're going to add straight down. So negative 1.25 plus 0.90 is going to leave us with negative 0.35t. And 13 plus 14.85 is going to be 27.85. Oh, I just made a mistake and I caught it. I didn't times that 13 by the negative 125. So we have to go back there. 13 times negative 1.25 is negative 16.25. So then when I add going down, I'm not going to get 27.85. I am going to get negative 1.4. And then divide by negative 0.35. And I get tulips equals 4. So there's 4 tulips. And then I know 4 plus something is going to give me 13. So 4 plus the daisies would be 13, and that would be 9. So there'd be 9 daisies.